Oh my goodness, hello guys. Today I'll come to you with the amazing illegal pics of Rowdy, True Ending, Halloween Candy, Ferris Bueller's Day Off. Oh my goodness, what does this mean? Well, let me tell you. Starting with dun, 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 Milestone 1, which goes over me, yes, me, Mark B. Flotis, and my chronicles of research. Specifically, what do I want to do? Well, I like math, I like calculus, I like mice. It is what it is. And therefore, I shall work at a research lab, not in a research lab, the McPherson lab. And with that information, we go on. What will be our expectations of a lab? Well, technically speaking, there is a biomedical research lab here in San Antonio based on military drive, which is fun based on my personal statement. My personal statement, given the fact that I like math, I said before, therefore I will now give money, much of money, to math scientists. And with that, we go to milestone 2. Now, before I start milestone 2, oh my gosh, that's SpongeBob. Yo, I just want to say that I forgot how to do buttons. So, if I were to make any comments on the Adobe webpage, it would be that I do not know how to make buttons. So, yeah. But I've gotten better. And thank you, Professor Cindy. My milestones had really high grades. But yeah, I just didn't do buttons the first few times. And when I uploaded them, they're uploaded without the links. Which is why when you do an interview, you must never forget the button, no matter what you do. No matter if you're riding a bike in the city with your dog, you must never forget your buttons. With that information, we go on to the 5 key criticals apart from buttons, which are basically plan your schedule, look professional, turn off the phone instructions, be concise, and above all, add some funny humor. If you want to be Spider-Man, then you gotta know how to do an interview. And with that, once you do an interview, Milestone 2 proves the fact that popcorn, not the popcorn, no, the group popcorn, on September 20th, has come to the idea to make not the best, but the best interview away. Because why you want a career? Well, why not? And using that information, using that specific Spider-Man approved question, we come with the fact that if you don't want to be a farmer child, I mean, who does? Oceanside, is Oceanside even a city? No, no, it's not. It's made up. Because if you want a job, you need to do an interview. And if you need an interview, you need experience. That's the end of the presentation. Now that's enough. Interviews, process, nobody likes that. This is a calculus class. Calculus, we use logarithmic equations. 41 plus 19 ln, x plus 1 now, bro. What about 41 drugs of 19 ln, logarithm of x plus 1 drug B, all makes drug C, because Professor Cindy has critical rat theory, and to save her from becoming the rat lord, we must give her logarithmic equations based on milestone 3. Now, real quick, I just want to shout out to our sponsors, Desmos. The only reason I'm passing my class, let's go. So, given this example, you can find logs, you can find Doritos, you can even find life-threatening quizzes. But I realize that this is calculus class, we accept chaos and Greek letters. And with that information, we come up with the derivative. Derivative is 19 over x plus 1. Given the fact the derivative of this equation means the specific play-by-play FPS of this graph. As in 19 drugs, x plus 1 drug B give us drug C. Specifically in the states where fx is equal to 1 is a new and improved function to the solution of drug C, which again may or may not save Professor Cindy from an overload of infliction and critical points. Thankfully, there are no points for this one, but if there were points, it would be the zeros and intervals of the graph. This graph, not a new graph, this beautiful, amazing graph, this logarithmic graph right here, shows the graph in our functions, which is basically, based on the graph right here, shows the area approximate under the graph, which is what we want, what we need, what we really, really want. The end. Let's go. Now, we move on to milestone 4, Raymond Sons. Now, everyone, who doesn't like logarithmic functions? What if I told you, man, that using Raymond Sons, you can find the area under a log function, not just any function, but under the function. So this function right here, this beautiful, amazing graph right here shows you that 25 minus 0.225 over minus double divided 0.260 squared equals the amount of not cheese, not powder, but jello in milliliters every mice gets in grams of weight. Let's go! As you see here is a left-hand sum with 2 graphs, not 1, not 2, 0.931, 1.62, 8 subintervals, not 1, not 3, 8 subintervals of differences, which change time of 0.9, again, provided by Desmos. And with that information, we go to the right-hand sums, beautiful sums, amazing sums, 10.5, 10.639, which again is an average of 10.57 with a rate, based on the formula, of negative 3.190. Let's go! With that information, we go on to the rat enthusiast. Now, this is a fancy, amazing, beautiful parts. And if you're not a rat enthusiast, well, you can leave now because this is calculus. Let's go. Based on calculus, again, we find the area into the graph. Area into the graph can give an approximation of what the logarithmic function is starting to find based on the two a and b values, which are the limits of the range. Squeak, squeak. For information, we go on to the endpoint interval c values. C values again, right hand sum, right hand sum. Is it a maximum? Is it a minimum? Who knows? All we know is that the graphs look really freaking cool. The end. Or is it? Milestone 5. Fundamental theory calculus. Now, if you want to see, I want a log, but I want to find the area. But not an approximate, no. I want the real play-by-play area. The exact area. Well, that's a fundamental theory calculus. Fundamental theorem of calculus finds not just one, not just two, but all balloons. In this beautiful graph, using the same graph, the only graph, the beautiful graph of milestone 4, we will find the derivative scenario. Again, it's still mice, it's still Joe. Who doesn't love mice? Using this mice, again, sponsored by Desmos, you find this to 5 data and of course, 15.95, 2. To find not 1, not 2, but 3 beautiful points, amazing points, ranged exact points of the previous graph of milestone 4. And with that, I can say that Riemann sums, and that's approximation, fundamental theory calculus, is an exact play-by-play range of 2 points to find the actual area on their graph. So with a heavy heart, I must tell you that, believe it or not, after all this calculus, after all this work, after all the horizontally spinning rats and buttons I may or may not have gotten to publish, we now get to milestone 6. A Boulevard of Broken Dreams, College Edition. No, this is not sponsored by Green Day. Given the derivative equation of 75 minus 0.3y, we have a scenario where 75 is the minimum Boulevard of Broken Dreams, minus 3 dreams out of 10 dreams, multiply by Boulevard's watch. We come with the beautiful, amazing scenario, or Phineas and Ferb is not Green Day. Because, well, why not? As for the solution, well, 250 is based on the solution equal to 0, where 75 divided by 0.3y is 250. 250 minus 250e, 0.3x gives us now the scenario, the solution, the amazing, beautiful equation, which will find the rate up and rate in of our things. Now, thankfully, both these equations, you assume to be rate out because we are increasing, but actually we are decreasing, which gives us now, again, of course, a rate up equation. As you can see, this amazing graph, which, as you can see, increases in the exponential graph until it becomes literally equilibrium at 250. Now, I like coding, so this part was actually really fun. But what isn't fun is the discussion. Well, the discussion is Euler's method, again, like Aaron says, an approximation, a belief system based on numbers. Numbers that you may or may not know aren't exactly, terribly correct. What are correct, however, is the analytical method. The analytical method provides a play-by-play equation on a graph starting from 0. Because as you can see, Euler should have 75, the minimum we initially created in the code. But to find the exact super chat believable amazing is the steps. The steps 2, 4. Yeah, you can kind of see that 4 isn't exactly very correct, or precise, not even accurate. But step 2 is pretty accurate and precise. There is a bit of difference, as you can see. Of course, 0, 75, there's a few difference. But as you can see, eventually you're just in equilibrium. But you might ask yourself, what is an equilibrium? Well, let me tell you, an equilibrium is a sort of carrying capacity. It is a rate point, a maximum, if you may, where the graph reaches, okay, that's enough. We can't handle anymore. So this scenario would be an example of how much sanity and coffee college needs before just dropping out of class and, playing Mario Kart. But that's not yet, because right now, we still have 75 minimum broken dreams per Boulevard's walked. And for that information, we can now somehow, some way graduate from college, because calculus is cool like that. So, because milestone 6 is a conclusion to all the other milestones, I may say based on milestone 1, I still like math, I still like science, I do want to work in a research lab. I may or may not have learned more about Adobe and calculus in this class, but at the end of the day, it doesn't matter because calculus is very cool. And with that, I bid you adieu.